Good morning, guys. We're going to continue our study today of rational expressions. We're going to look more in depth at what complex fractions are and how we simplify complex fractions. All right, so first, a complex fraction is just a quotient that has a fraction in the numerator, a fraction in the denominator, or a fraction in both. All right, so we're going to have to try to simplify those. And by doing that, we have two methods that allow us to do that. The first method says we want to simplify the numerator and the denominator separately. And once we've done that, we want to divide fractions. But remember, when we divide fractions, we really are keep, change, flipping. And then the third step is we want to simplify if possible. All right, so that's method one. Method two says we want to find the LCD of all the denominators and then multiply my denominator and my numerator of my complex fractions by the LCD, and then we'll simplify that answer if possible as well. All right, so here are two methods. I'll show you both methods, and you can determine which one you like best. Some problems work best with one method, some problems work best with the second method, but you can decide which one you like and want to use. All right, so let's look at some methods. So this is method one. So I have x plus 1 over x over x minus 1 over 2x. All right, so method one says we want to simplify the numerator and the denominator separately, which in this case, they're both simplified already. So then step two says we want to divide them. So we just want to keep, change, flip. So x plus 1 over x times, flip the second one, 2x over x minus 1. All right, we can cross simplify. My x's here will cancel out. And now we can multiply our fractions. So x plus 1 times 2, well, that's just 2 times x plus 1. And on the bottom, we just have 1 times x minus 1, which is just x minus 1. And third step, see if you can simplify any more, but in this case, we can't. So our final answer is 2 times x plus 1 over x minus 1. All right, so that's method one. Let's look at the same problem. So this time we'll use method two. So again, x plus 1 over x over x minus 1 over 2x. All right, so method two says first we need to find the LCD of my denominators. So here I have x and 2x, and if we remember back to LCD, our LCD here would be 2x. So now that we know the LCD, method two tells us to multiply the top and the bottom of our complex fraction by that. So I have 2x times x plus 1 over x on the top, and on the bottom I have 2x times x minus 1 over 2x. All right, we can cross simplify once again. My x is canceled on the top, leaves me with just 2 times x plus 1. And on the bottom, my 2x's both cancel, and I'm left with x minus 1. And if we notice, we get the same exact answer we got when we did method one. So either method would work, but there will be times where one method works better than the other. All right, so now let's look at some more examples. All right, so here we want to simplify 35 over x minus 2 over 14 over x. All right, well here I think I would like to use method one. Okay, I think method one would work best here, so let's try that. And the reason why I say that is because everything's already simplified. My numerator and denominators are already simplified for me. So I get to skip that step right away, and all we have to do is divide our fractions or keep, change, flip. So I'm going to keep my top fraction. I'm going to change my division and multiplication, and then I'm going to flip my bottom fraction. Again, we can cross simplify, divide the 14 by 7, we get 2, 35 by 7, and we get 5. Now we just multiply across. 5 times x is 5x. X minus 2 times 2 is just 2 times x minus 2. Now remember, we can't cross out the x's because this x is with the 2. It's x minus 2. It's not factors with 2. All right. So that's how far as we can go. 5x over 2 times x minus 2. All right, good. Now I want you to try one of these. So you have 9z to the 5th times x to the 7th over 49 over 63 x to the 5th z to the 7th over 35. All right, so pause the video, give yourself a few minutes to work it out, then we'll come back together and check your answer. All right, so now let's check your answer and see how well you did. Again, I'm going to use method 1 for the same reason over here. My numerator denominators are factored and look nice. So all we have to do is keep, change, flip. 9z to the 5th times x to the 7th over 49 times, I'm going to flip this one, give me my reciprocal, 35 over 63 x to the 5th z to the 7th. We actually got a lot of cross simplifying we can do. Now remember, you do not have to cross simplify, but it saves you in the end, makes your numbers a little smaller so you don't have to work with such large numbers at the end of the problem. I can divide 49 and 35 both by 7. That gives me 7 here and 5 up top. I can simplify 9 and 63. Gives me a 1 here, a 7 here. Here I have 5 z's, here I have 7. So these 5 will cancel with 5 of these, leaves me with 2. And then the same thing with my x's. These 5 cancel with 5 of these and leaves me 2 x's. So what we are left with now is 1 times x squared times 5. So that's 5x squared on top over 7 times 7 times z squared. 7 times 7 is 49, and then z squared. So we're left with 5x squared over 49z squared. All right, very good. All right, let's look at a couple more examples. All right, so we got 6 over z plus 7 over y in my numerator, and then 9 over z minus 8 over y in my denominator. Well, if you look here, my numerator and denominators aren't nice and neat, okay, so we would have to do work with them. So I'm going to try method 2 and just see how it works out. So method 2 says first, I need to take all my denominators. So I have 1, 2, 3, 4 denominators total. I need to take all of those and find my LCD. Well, my LCD would just be z times y. So now what step 2 tells me is I'm multiplying everything by that z times y. So I'm going to have z times y times 6 over z plus 7 over y times z times y over my zy times 9 over z minus my 8 over y times my zy. So I'm multiplying every single term by zy, and now we're going to see what cancels out. So here my 2 z's cancel, leaves me with 6y, plus, here my y's cancel, so it leaves me with 7z, over, on the bottom my z's cancel, leaves me with 9y, minus, my y's cancel here, minus 8z. And if you notice, there's nothing else that we can cancel out or cross out. That's as simplest as we can get it. All right, so if you notice, I think method 2 in this problem worked a lot better than method 1 would have. All right, very good. I want to give you one similar to this to try now. So 1 over c plus 1 over g over 1 over c squared minus 1 over g squared. All right, so pause the video, give yourself some time to work this out, then we'll come back together and we'll see how well you did. All right, so now let's look and see how well you did. So the first thing we need to do, I'm going to use method 2. So the first thing I need to do is find that LCD. Well, if we look at all 4 denominators, my LCG would be c squared times g squared. So now what method 2 says, we multiply every term by c squared g squared. So times 1 over c, 1 over g times c squared g squared over c squared g squared times 1 over c squared minus 1 over g squared times c squared g squared. So there I'm just multiplying everything by the LCD. And now let's see what cancels out. So here, one of these c's cancels this c out. So I'm left with c times g squared times 1, which is just cg squared, plus this g cancels with one of these. That leaves me with c squared g over, here my c squared cancels. So I just get g squared minus g squareds cancel minus c squared. All right. Well, now let's see if we can factor anything out. So what can we factor out of the top that they have in common? Well, let's just factor a c out and see how that works. So if I factor just a c out, I'm left with g squared plus cg. All right. Well, if we notice, there's more that we can take out, right? We can actually take out AC times G. So let's do that. So we can take out CG. That's going to leave me with G here plus C over here. And one way to remember you can check your answer is to multiply back through. CG times G is CG squared. CG times C is C squared G. All right, so that does check out. And if we notice here, well, that's just difference of squares. Okay, so we should know how that factors. So that's G plus C times G minus C. All right, now we just need to see if we can simplify. Okay, which we do have common factors of G plus C's, so they cancel each other out. And so we're left with CG over G minus C. Now remember, we can't cancel anything else there because the bottom is not factors. They're G minus C and the top is C times G. And that's our final answer.